In this presentations, we are going to discuss about the runtime environment and code optimization. So, where this first important topic is issues in the design of code generator. So, the issues in the design of code generators are input to the code generator, target program, memory management, instruction selection, register allocation and evaluation order. So in this input to the code generator, actually the code generation consists of the intermediate representations of the source program produced by the front end together with the informations in the symbol table to determine the runtime address of the data object denoted by the names in the intermediate representation. And it also get the input in the form of linear representations such as the postfix notations, three address representations such as quadruple, triple and direct triple. So the virtual machine representations such as the byte code and the stack machine code. The graphical representations is the syntax tree and the DAGs. And the target programs, actually the compiler generated target code is in machine code, and it has a significant impact on the difficulty of constructing a good code generator that produce a high quality machine code. So the most common target machine architectures are the RISC architecture and the CISC architecture and stack based. So the RISC machine typically has many registers, 3 address instructions, simple addressing modes and the relatively simple instruction set architecture. So the target address code with the CSI machine typically has a few registers, 2 address instructions, a variety of addressing modes, several register classes and variable length instructions and the instructions with the side effects. So in the stack based machine, operations are done by pushing operands onto the stack and performing operations on the operands at the top of the stack. To achieve the high performance, the top of the stack is typically hit in registers. So the stack based machines almost disappear because the stack organizations was too limiting and required too many swap and copy operations. So in this memory management, names in the source programs are mapped to address of the data object in the runtime memory by the front end of the compiler and the code generator. So labels in 3 address statements have to be converted to address of the instructions. So examples, the jump instructions, that since go to I generates the jump instructions as follows, where if I less than of j, a backward jump instructions with target address equal to the locations of the code for quadruple I is generated. If I is greater than of j, the jump is in forward. So we must store on a list of quadruples I locations of the first machine's instruction generated by the quadruple j. And the instruction selections. So the proper instruction selections is very important to improve the quality of the target code. So it must be complete and uniform. So instruction speeds and the machine items are important factors when efficiency of the target program is considered. So example, consider the instructions x is equal to y plus z that can be converted into assembly language by using load and store instructions ld r0 comma y and add r0 comma r0 comma z and store x comma r0. So this is an efficient instructions. So registers allocation, the proper register allocations is also improve the code by minimum memory space. So here instructions involves registers operands are shorter and faster than those involving operands in the memory. So the use of registers is subdivided into 2 subproblems. Register allocations, register assignment. The set of variables that will reside the registers at the point in a program is selected. So the registers assignment, the specific registers that a variable will reside in is picked. And the evaluations order, the order in which the computations are performed and the effective manner it give a efficient target code. So some computations order required fewer registers to hold the intermediate results than others. Thank you.